Okay, so I'm moving to question number 5 in the October 2020 Statistics Paper 1. They say a large company rents shops in different parts of the country. A random sample of 10 shops was taken and the floor area X in 10 square meter and the annual rent Y in thousands of dollars were recorded. The data are summarized by the following statistics. So sigma X square, sigma Y square values are given to you. And the regression line of Y on X has the equation is also given to you. Regression line is provided. They say use the regression line to estimate the annual rent in dollars for a shop with a floor area of 800. So how do you get the, they're asking you to calculate the, so they're asking you to calculate the annual rent in dollars for a shop with a floor area of 800. So what are you supposed to do here? So they have told you the floor area. Now, you know the floor area is our which variable? The floor area is the X variable. However, bear in mind the X variable is measured in tens, right? They say in 10 square meters. So if you are measuring your X variable in 10 square meters, what is the X input? Are we going to go and use X as 800 in this regression line? No, what's the X input that we use? We are going to use X as 80. Okay, so yeah, X input is 80. In this equation, X is in tens and Y is in thousands. Remember that. Okay, so in part A, your input X is going to be 800 is taken as 80 because we are taking it in tens. So substitute that and get the annual rent 6.066 plus 0.136 into X is 80. How much is Y? Can I have the answer here? 6.066 plus 0.136 into 80. How much is the answer? 16.946 $16.946. But 16.946, is this the final answer? The thing is, they tell you that Y is measured in thousands of dollars. Y is measured in thousands of dollars, which means it is $16.946,000. Are you with me? So final answer, if you could multiply and get this $16,946,000. Okay, so make sure this is the annual rent and this is how you should give your final answer. The next one, SYY. So SYY equation is sigma Y square minus sigma Y whole thing square divided by N. Sigma Y square is 3,434 minus sigma Y square, sigma Y whole thing square, that's 183 square divided by N. What's our N value? They say a random sample of 10 shops was taken. So they are taking the sigma X, sigma Y by taking the data values from 10 shops. So N is 10. Can I know the SYY answer? 85.1. 85.1. Then the SXX value, sigma X square minus sigma X whole thing square divided by N. Sigma X square is 84,818 minus sigma X is 900 divided by N is 10. So this is the 900 square. Can I have the answer for SXX? 3,818. Everyone is clear with it? This is the answer for part B. Part C, they ask you to find the product moment correlation between Y and X. Okay. So how do you get the product moment correlation between Y and X? So normally product moment correlation is SXY over divided by square root of SYY into SXX. So now you can see we have a small problem here. What is the problem? Now we have SXX, we have SYY, but there is another person that I need here to calculate that is SXY. So do I have any information here to find SXY? Normally we find SXY by using sigma XY minus sigma X sigma Y over N. So these are equations provided to you. But in this question, you can see sigma XY is not given in this data. Sigma X, sigma Y are there, but sigma XY, this crucial value is not given here. So then how do we find SXY? So what's an alternative approach? So you can see that they have given you the regression line. So the regression line is in the format. What's the format of the regression line? Normally we write Y equal A plus BX, right? Y equal A plus BX, where B equals SXY over SXX and A equals Y bar plus BX bar. Isn't it? So, so here we can write R equals, before finding R, let's find the B value. B equals SXY over SXX. Are you with me? So these are standard formulas. So B value is given, the coefficient of x 0.136. So B value is 0.136. Sxy is what we are trying to find. Sxx was the value that we found here, 3,818. Can you all get me the Sxy value? Multiply 0.136 with 3,818. How much is it? How much? 519.248 Sxy. So everything is ready now. We can go to find the R value. So R equals Sxy divided by root Sxx times Syy. So Sxy is 519.248 divided by square root of Sxx is 3,818. Syy is 85.1. Is this okay? Do you agree with the substitutions? Can I have the R value? 0.9. Tell me more figures. 910944. Okay, 4. So when you give it to 3SF, 0.911. Okay, so this is the product moment correlation coefficient. So you can see it's a strong correlation. We have a strong correlation here. It fits to a linear model. A strong positive correlation. Thereby it fits to a linear model. Okay. Okay, so they are not asking you to describe anything here, but just to get the R value. So that was just giving you an idea what it means. Okay. So we found the product moment correlation coefficient. Now they are asking, okay, so now we have a new part. Look at part D. They say a 11th shop is added to the sample. Okay, you are adding another shop. So you already have 10 shops. These summary statistics were given for the 10 shops. So now we are adding 11th shop to the sample. The flow area is 900. Flow area is 900 means what's the 11th input for X? Now, you know, flow area is your X input, the X input. So what is the 11th X value? X11 is 900 means you do realize 900 is, we are measuring X in 10. So the X value that we input is 90. Are you with me? The flow area 900, which means your 11th value, the X11 is 90. By X11, I mean X1 is the flow area of the first shop. X2 is the flow area of the second shop. Okay, so your variables X1, X2, X3, we have the summary statistics for the first 10 variable, X1 through X10. So they're adding another new variable. That's why I use as X11. Okay, so the flow area is 900, which means our input for the X value is, because it's measured in 10, the input is 90. And the annual rent is 15,000. So what's the annual rent is the Y variable, right? So this is the 11th shop, which means this is the Y11 variable. Okay, Y1 through Y10 variable summary statistics are given here from Y1 through Y10. So this is the 11th variable. Okay, so what is Y11? You know, Y is measured in thousands of dollars. So thereby, what's the input we use here? $15,000 is the annual rent. What's the Y11 input? Since you are measuring Y in thousands, Y will be 15. Do you agree? They are asking you use the formula Sxy equals sigma x minus x bar and Sxy equals sigma x minus x bar into y minus y bar to show that the value of Sxy for the 11 shops will be the same as it was for the original 10 shops. Okay, so you have to show that Sxy doesn't change. Okay, so first what we will do is let's calculate the x bar and the y bar. Let's see whether there is whether these values are changing or not, right? Okay, so what about the previous x bar? So for 10 shops, just 2 marks. Okay, so for 10 shops, what was our x bar? The x bar was 900 divided by 10, right? Which is 90. Can you see the x bar for 10 shops is 90? Now, the new x value that you are adding here is what? The new x value that you are adding here is X11 is also 90. So you should be aware that when you are adding a new variable to an already existing set of data, and if that new variable is equal to the mean of the previous set of data, then that adding that new variable will what? will not make any difference. Will not make any difference to the mean of the new data set. Okay, so if, for example, now we are the mean of the 10 shops is 90. If you are going to add a new shop that has a floor area of 100, what happens? The mean of the 11 shops will increase. Okay, so if you're adding a, so in this case, because the mean, the X11 value is 90, which is exactly equal to the mean of the 10 shops, adding the 11 shop will make no difference to the X bar. Do you understand that? So for 11 shops also, the X bar sigma X, you can even calculate sigma X. So when sigma X is, you have the sigma X for 10 shops 900. So you're adding another shop that is 90. So 900 plus 90 is the sigma X now. 990 is the new sigma X. Divide by n is 11. So 990, if you divide by 11, you end up getting 90 again. Okay, so your new X bar is also 90. There is no change in X bar. Okay, previous X bar and new X bar are exactly the same. Do you agree with me? Yeah, so this is part D, right? Yeah, this is part D. Okay. So X bar, there is no change. Okay, what about the Y bar? Actually, what about the Y bar? So for Y bar, I think you can see Y11 is 15, but you can see, I think the Y bar value is changing, isn't it? The Y bar value, so your sigma Y is 183. When you divide by 10, the previous Y bar is 18.3. But the new Y bar, so you can see the new Y you are adding is Y11 is 15. Are you getting what I'm saying? The previous Y bar, sigma Y divided by 183 divided by 10, the Y bar value was 18.3. But now you are adding a shop that the Y11th value you are adding is 15, which is lower than Y bar. So that means definitely the new Y bar will decrease because you're adding a value lower than the existing mean. Okay, so the Y bar value for the 11 shops will decrease. Okay, okay. Anyway, the most important thing is you do realize that one of the variables don't change the mean. The mean of the X variable is not changing. So when you add the SXY, when you get the SXY, this is just 2 marks. So sigma XY, when you take SXY, how does SXY work? So you realize SXY is sigma X minus X bar into Y minus Y bar, right? Okay, so which means when you take it for the 11 shops, this is the first X variable minus the X bar, Y1 minus Y bar. Can you see how we manually work with it? So you input the first X value, subtract from the mean of the X value into the first Y value, subtracting from the mean of the Y value. So likewise, you go on until X10 minus X bar, Y10 minus Y bar plus the next value because we are taking the SXY for 11 terms. X11 minus X bar into Y11 minus Y bar. Can you see how we can manually expand this? So you will, there are many terms in the middle here. X2 minus X bar, Y2 minus Y bar, plus X3 minus X bar, Y3 minus Y bar. Okay, this I just showed you how to expand this manually. So anyway, the extra term you're adding here is this guy. And what do you have to say about X11 minus X bar? So you can see the X bar value is 90. And the 11th X value is also 90. Can you see the 11th X value is also 90. X bar is also 90, which means this extra term that you are adding is what? Is 0. Okay, is 0. Can you see the X minus X bar? The new term X minus X bar will be 0. Okay, so this term, you can say this is going to be 0. Okay, this is going to be 0. Thereby, this product, okay, this answer, you can say the 11th shop, therefore SXY stays the same. Okay, so you can write SXY. Even though the Y bar changes, actually even the manual calculation, I mean, you must know it, even though the Y bar changes here, this will not make any effect on the SXY. Okay, it will make no effect. Since one of the means are remaining constant, this value will not change, especially the term that you're adding here, it becomes 0. Okay, because X11 is 90, X bar is also 90. So therefore, this is 0, 0 multiplied by whatever here, the entire term is a 0. Okay, so remember when the mean of one variable is remaining the same, Even though the other variable mean is changing, it will not. Now in this case, the x variable has the mean constant. It doesn't change. The y variable mean is changing, but in such situations, remember SXY doesn't change. So it's just a 2-mark question. Just give a, you just have to give a small justification. Okay, say the x bar is the new x bar is not changing. Therefore, the SXY, the 11th term is 0. Therefore, SXY is remaining unchanged. That's all you need to say. Then moving on to part E, they say find the new equation of regression line of y on x for the 11 shops. Okay. So how do we get the new equation of regression? Basically, you have to get the b value, the y equal a plus bx. You have to get the new a and b values, right? So you can see the b value is sxy over sxx. What do you have to say? Now we just found out sxy, does it change? Sxy doesn't change, isn't it? There is no change. So what happens to sxx? Do you think sxx is going to change? Since the x variable mean is not changed, you saw that x variable, the mean for 10 shops and mean for 11 shops is exactly the same. So in that case, adding the new variable will make no effect on sxx. There's no change. Okay, so it's really important when the mean of a certain variable doesn't change. That means, so mean of the x variable doesn't change means the sxx and sxy will not change. Okay, really important. And then, however, I think that's not the case for the y variable, right? Y variable, we have a new mean. Okay, so anyway, b value doesn't change. However, to get the a value, a is y bar. What's the a value is y bar minus bx bar, right? Okay, so what about the y bar value? Can we get the new y bar? So new y bar sigma y over n. Previous sigma y was 183. So you have to add the new y value. What was the new y value? I told you the 11th y value is 15. So for 183, you have to add 15. 183 is the addition of the 10, the rent of the 10 shops. So you're adding the 11th shop 15 divided by what? 11. You have 11 shops now. Can I know the new y bar? How much? 18. The new y bar is 18. Okay, so then let's get the a value. Can you all calculate the a value? Y bar minus b is, how much was the b value? B value was 0.136 here, right? This value bx 0.136. So b y bar minus bx bar is, there's no change. We found x bar was how much? 90. Can I know how much is a? 5.76. So then the equation of the regression line y equal a plus bx. So y equals 5.76 plus b is, b value is exactly the same, right? 0.136. Agreed? Okay, let's move to the next part, part F, the last part. The company is considering renting a large shop with area of 3,000 square meters. Comment on the suitability of using the new regression line to estimate the annual rent, give a reason for your answer. Okay, so what do you have to say about this value 3,000? Now, you know, when you are using the x value 3,000, x is measured in tens again. What's the input? So what are we using for the input here? X input is how much? 3,000 means what's your x input? You are trying to input x as 300 because it's measured in tens. You are trying to input x as 300. So what is the problem in inputting x as 300? The problem here is you need to decide whether 300 is in the range or outside the range. You need to decide whether it's in the range or outside. Okay, so how do we decide whether x equals 300 is actually fitting into the range or not? Normally we say data values that fit into the range is actually like this, mu plus 3 sigma. This is our level of tolerance. Okay, so 3 sigma away from the mean. Okay, so normally we say mu plus or minus 3 sigma. So if any x value is exceeding this limit, it's an outlier or it's outside your range. It's outside the range of your accepted data values. Okay, because the problem here is they have not given you any lowest x now. There's no data set given here. Okay, there's no data set given here. So when there's no data set given here, you can use these boundaries to decide whether a given x value is an outlier or not. Are you with me? Okay, so I have written here an equation how to get the sigma. So sigma is root sxx over n. You need to know this equation. This is the main equation. Sigma equals root sxx over n. Sxx value for x is 3818. There's no change. Divided by n is 11. So we get sigma is 18.63. Okay, so here mu plus 3 sigma value. So this is the tolerance interval. Mu plus or minus 3 sigma is what we consider as the limits. So if you're jumping outside these limits, any x value that jumps outside is outside the range. So you can get here mu plus 3 sigma is 145.9, which and you can see our x value is 300, which is definitely what? Outside the range. So however, this is just a 1 mark question. Okay, so it's just a 1 mark question. So you can say anyway, it's that x equals 300 is outside the range. Yeah, it's outside the range or it is an extrapolated value. Okay, so therefore, is it suitable or not? So it's not, therefore, we cannot rely on the answer, rely on answers taken from extrapolated values. Okay, so not suitable. It is not suitable. Okay, is this clear? Okay, so moving on to the last question in this paper. The random variable capital A represents the score when a spinner is spun. The probability distribution for capital A is given in the following table. Okay, so they have given you the probability distribution for the variable A when the spinner is spun. Show that expected value of A is 3.5. How do we do that? How do you get the expected value of A? You multiply the A value with the probability that A, with the probability of each respective term. So here A is 1, probability 0.4 plus A is 4 into probability 0.2 plus A is 5 into probability 0.25 plus A is 7 into probability is 0.15. Can I know how much is this? How much? 3.5. So it's 3.5. Okay, so it's a show that, but anyway, you have to show the working. Make sure these workings are there to be seen in order to receive the full marks. Part B, they are asking you to find the variance A. Before finding variance A, what should we find? We have to find the EA square value. So EA square value is 1 square into 0.4 plus 4 square into 0.2 plus 5 square into 0.25 plus 7 square into 0.15. How much is the value for EA square? 17.2. So we'll get variance A. Variance A is EA square minus EA whole thing square. So EA square is 17.2 minus expected value of A is 3.5 whole thing square. How much is variance A? 4.95. Okay, so this is the answer for part B. Are you clear? Then moving on to part C, the random variable capital B represents the score on a four-sided die. The probability distribution for B is given in the following table where K is a positive integer. Can you see? So your integers on the four-sided die, the values are 1, 3, 4, K. And can you see the probability distribution here? The probability distribution, as you can see, all the sides are having what? Equal probability. So when it's an equal probability, what do you call these distributions, such distributions? So this is discrete. You can see each and every x value is separately given and each x value has the same probability. So that's a special name we give for that. This is discrete uniform distribution because it's the probabilities are uniformly distributed. So that's what they ask in part C. Write down the name of the probability distribution of B. So in part C, you will write the name as discrete uniform distribution. Okay, so it's a discrete uniform distribution. Then in part D, given that expected value of B is equal to expected value of A, state giving a reason the value of K. So what's the expected value of B equals to expected value of A? I think we found the expected value of A for 2 marks in part A. The expected value of A was 3.5. So they are telling you the expected value of B is also 3.5. Okay, so that means the average value of the X variable is 3.5. So then they are asking you based on that to give the K value. So no additional calculations are required because they just give it for 1 mark. Okay, so you don't need to perform additional calculation by doing 1 into 0.25, 3 into 0.25, and then making the answer equal to 3.5 and making K the subject. It's not necessary. Okay, so look at the expected value of B, it is 3.5. So where does 3.5 fall within this range of B values? You know, it gives the average B value, right? So what's the average B value here? You can see it's 3.5 exactly in the middle of 3 and 4. And also now, you know, these average values are weighted according to the probabilities. So if a certain person has a higher probability, then the average is more inclined towards that person. Do you get what I'm saying? So here, do we have any any B value who has any who has more preferences? No, everyone has the same probability. So it's inclined towards everyone in an equal manner. However, now you can see the mean has come. The mean is exactly the middle of 3 and 4. So thereby, can you guess what should be the K value? If you look at the symmetry. So this is what we consider as by the symmetry of this. So according to symmetry, what should be the K value? Behind 3, I have 1. So in that case, after 4, what should be the K value? Should it be 5? Should it be 6? Should it be 7? So from 3 to 1, you have a gap of 2, right? 1, 2, 3. So there's a gap of 2. Thereby from 4 to K also there should be a gap of 2. Thereby K should directly be what? K should be 6. Okay, so you can say K equals 6 by what? By symmetry. It's because of the symmetry. Now remember, we would not be able to do this if these probability values were different. Okay, if the probability values were different, you have to definitely multiply and do it in the long way. Since the probabilities are different, every B value has an equal chance. So we can say that it's equally, we can take the symmetry and do the sum in this case. Okay, so now we come to the challenging part in this question. So they say here the random variable X follows a normal distribution mu comma sigma square. Mu is the mean, sigma square is the variance. Sam and Tim are playing a game with the spinner and the dice. They each spin the spinner once to obtain their value of A and each roll the die once to obtain their value of B. Can you see what's happening here? So now you have two distributions here. One for the random variable A, which is a spinner. Random variable B is a dice, a four-sided die. So they are playing a game. In this game, yeah, they both spin the spinner and they also toss the die. And they take the output of the spinner and the dice. Okay. So they say they each spin the spinner once to obtain their value of A and each roll the die once to obtain their value of B. Their value of A is taken as their value of mu. Okay. So their value of capital A, this value, so either it's going to be 1 or 4 or 5 or 7, isn't it? So that's going to be the mu value and their value of B is taken as sigma. The B value is taken as sigma. The person with the larger probability X greater than 3.5 is the winner. Okay, so the person who has the higher probability for X greater than 3.5 will be the winner. So in part E, they say given that Sam obtained values of A equal 4 and B equal 3 and Tim obtained B equal 4, find giving a reason the probability that Tim wins. So you have to find the probability that Tim wins. Okay, so this is just 2 marks. But the amount of thinking here, so you have to do a little bit of thinking here. But so 2 marks, it should tell you the method is not that complicated, but you need to find out how to do this in the easiest way. Okay, so this is what we do now. They tell you here the mu and sigma values for Sam, right? So what are the mu and sigma values for Sam? In part E, for Sam, they have told you A is 4 and B is 3. Are you with me? So then we can get the Z value, right? So we can calculate now we are supposed to, they are telling you that the person who has the larger probability X greater than 3.5 is the winner. Are you with me? So this is the normal distribution. Look at this. So you have the normal distribution. The mean is mu. So anyone who has the larger probability x greater than 3.5. So let me randomly assume the 3.5 is over here. It could be anywhere on this axis. Okay. So anyway, the person who has the larger probability x greater than 3.5, this area. Are you with me? The person who has the larger probability of x greater than 3.5, x greater than 3.5 is this area. So the person who has this area as their largest area will be the winner. Now you do realize when mu and sigma changes, the position of the 3.5 will change. Okay, so you know when you convert to standard normal, mu becomes 0, the standard normal. And what about the 3.5? Can I have the z value, the respective z value of 3.5? How do you get the z value? Z equals x minus mu over sigma, right? So x in this case is 3.5 minus mu over sigma. Are you with me? So when the mu and sigma value changes, so let me take this as 3.5 minus mu over sigma. This is the, I'm drawing the standard normal distribution now. So anyway, when your mu and sigma value changes, you do realize the position of this place is changing. So then they say the person who has what? The highest probability of x greater than 3.5. So this area, the shaded area, the person who has the higher shaded area will win. So for the if they need to have the shaded area is supposed to be higher, what do you think about the z value? So the person who wins should have a higher z value or a lower z value. Look at the z value here on the x-axis. So you can see if the z value comes behind, you have a higher area greater than that, right? The greater that area gets larger. You get what I'm saying? If now now your mu and sigma are variables, isn't it? The mu and sigma variables are decided by what you get from the spinner and what you get from the dice. Okay. So then you do realize according to the mu and sigma value, this position will change. This position will change. So this position, if it moves behind over here, do you see that if the 3.5 minus mu over sigma comes here, then this person has a higher area for x greater than 3.5. Do you see? So then to win here, the requirement is that the person who wins will have the lower z value. Okay, the person who wins will have a lower z value. The comparatively lower z value person should be the winner. Okay, so now let's get the z value of Sam. We actually have Sam's a value and b value, right? So I'm going to get the corresponding x value for the corresponding z value for x 3.5, right? They have told us capital X value is greater than x is 3.5. So I'm going to get the corresponding z value. Calculate me the z value. For Sam, 3.5 minus mu is 4, right? Sigma is 3. How much is this? This is the z value for Sam. How much is the z value of Sam? How much? Minus 1 over 6. Z value of Sam is minus 1 over 6. Do you agree? Okay, so now they tell you to find the probability that Tim wins. Now you can see, however, in the case of Tim, what have they given us? In the case of Tim, what have they given us? They have told Tim obtained B equal 4. They have told Tim obtained B equal 4. And they say fine, giving a reason the probability that Tim wins. Okay, they have not given us the A value. So that means you have to decide what are the A values here that will actually give you a win. Okay, so then for Tim to win, let's get Tim's Z value corresponding to x 3.5. You do realize that as mu and sigma changes for x 3.5, the Z value will change. Okay, so let's get the Z value of Tim. 3.5 minus mu is unknown, divided by sigma is 4. Are you with me? So if you want Tim to win, okay, so find the probability that you have to find the probability Tim wins. If you want Tim to win, what's the requirement when you compare the Z value of Sam and the Z value of Tim? The person who wins will have what? The lower Z value or the higher Z value? The person who has the greatest probability, x greater than 3.5, this probability, the person who has this highest probability will win. If the probability that x greater than 3.5, the person who has the larger probability of x greater than 3.5 is the winner. So for this probability, this shaded probability to be higher, should your Z value be in front or should it go behind? Should it go to the right or to the left? If your Z value is to the left, then you get a more area shaded for the greater than side. The person who has the larger probability of x greater than 3.5 is the winner. Are you with me? So if one person has the Z value, so if Z value of Sam is over here, and if Tim gets his Z value over here, okay, so this is the so the probability X greater than 3.5 for each of them have three different Z values. Why are the Z values different for a constant value of X 3.5? Why are the Z values different? Because they are having different mean and sigma. The mu and sigma is changing. That's why the Z values are changing. Okay, so the person who has the higher probability, now you can see here, is it greater than T? This area is higher. In this case, Tim will win because Tim has a higher probability for X greater than 3.5. Okay, so we need to find the probability that what? Tim wins. So if Tim wins, then Tim should have the comparatively lower Z value. Then the probability of Z greater than the greater probability is higher for Tim than for Sam. Are you with me? Okay, so then let's input the value. Z value of Sam is minus 1 over 6. Greater than Z value of Tim is 3.5 minus A divided by 4. Can you all get me the A value here? Minus 1 over 6 multiplied by 4. 4 is a positive integer. When you bring it to the other side, does not make any impact to the inequality sign. So I get here minus 2 over 3 greater than 3.5 minus A. So minus A comes here as plus A. So I'm not bringing as a multiplication or division. Minus A comes as addition. Minus 2 over 3 I'm taking here as addition again. How much is this? 3.5 plus 2 over 3. How much? 25 over 6, which is 4.166, 4.17. So which means what? If Tim is supposed to win, the A values that Tim get, now you know A is the value you get from the spinner. So the A values that you get from the spinner must be bigger than 4.17. So if you get A values bigger than 4.17 from the spinner, then Tim will win. So what are the values bigger than 4.17 on the spinner? Because A variable you get from the spinner. What are the values we can get from the spinner? So 5 and 7. So if Tim gets values of A, either 5 or either 7, then he can win this game. Okay. So then what's the probability of Tim winning this game? So what's the probability of Tim winning the game? You have to get the probability. So A has to be 5 or 7 for Tim to win the game. So get the probability of A is 5 or A is 7. Do you understand? The probability that Tim wins. Probability Tim wins is when A is 4 and when A is 5 and A is 7, right? Do you agree with what I'm writing? Can I know the probability of A equals 5? What's the probability of A equals 5? 0.25. What's the probability A is 7? Add these two and get me the probability that Tim wins. 0.4. So this is the probability that Tim actually wins the game. Okay, so the most important thing you need to realize here is the probability X greater than 5. When you take this probability, when you take the Z value corresponding to this, because the mu and sigma changes, the Z value for each person is changing accordingly. Okay, so the person with the higher probability of X greater than 3.5 is the person who wins the game. So in that case, the person with the lower T value, the lower Z value is the one who wins the game, because the lower the T value, the higher the greater than probability. Okay. Okay, then moving on to part F, they say find the largest value of probability X greater than 3.5 achievable in this game. Okay, so again, they ask you to find the probability, the largest possible value of the probability X greater than 3.5. So once again, when you make this into the Z value, this is Z equal 3.5 minus mu over sigma. So you need to realize to get the largest probability for 3.5 minus A over B, you'd need to realize to get the largest possible probability, we need our Z value to be as large or as small. Again, the same question as the earlier one. So if 3.5 minus A over here, if you take Z greater than, so this is the area we shade. So I want this shaded area to be as large as possible. So if the shaded area is to be as large as possible, I need this point to move as further back as possible. So the lower your z value, the higher the probability of z greater than 3.5, of x greater than 3.5. So I want this 3.5. So I want the smallest possible answer for 3.5 minus a over b. The smaller the z value 3.5 minus a over b, the larger this area is gonna be. Okay, because if you take it behind, then you have more, you can color a bigger area. So this yellow area is higher than the red area. So I want you to now tell me. So you know, yeah, A and B values are taken from the spinner's outcome and the dice outcome. So what is the best value to use for A, and what is the best value to use for B here? Here we have K is 6. Okay. So how do we use? What's the best value? Now I want this answer to be as small as possible, which means for the numerator A, what's the value I should use? Should I use the smallest A value or should I use the highest A value to get the smallest answer possible? Should I use A is 1 or A is 7? You know, your A has to be either 1 or 4 or 5 or 7. So since I want my Z value to be as small as possible, I should use A as 7. Are you with me? So to get the smallest value for smallest Z, you realize A is 7. Are you with me? So if A is 7, now we realized our A value is 7, but B is going to be a little bit tricky because we normally think, okay, so in inverse proportions, we think that the denominator should be as what? To get the lowest value, the denominator needs to be as large as possible. We think like that. But in here, do you see 3.5 minus 7 is a what answer? What is 3.5 minus 7? It is negative how much?
3.5.
Minus 3.5.
3.5.
Yeah, minus 3.5 divided by B. So now you need to check the B value here. Out of 1, 3, 4, and 6, what is the B value that is capable of giving you the smaller Z value? Should we use B value 1 or should I use B value 6? Should I use B value 1 or 6? If you use B value 6, do you see that when you divide with 6, you get the negative value is, you get it over here on the negative scale, minus 3.5 over 6. How much is minus 3.5 over 6? Minus 0.583. But if you do minus 3.5 divided by 1, it's minus 3.5, which is further back. Can you see? So in this case, don't go to use the denominator should be as high as possible and use B 6, because if you do, that number is actually larger because the denominator is negative. Sorry, because the numerator is negative. Do you understand? So in this case, the value of B, to get the smallest Z value, your B value should be what? For smallest Z, A should be 7 and B should be 1. Is this clear? So they want you to find the largest probability also. So get the probability X greater than 3.5. Is probability Z greater than 3.5 minus mu is 7 divided by 1. So you have to get the probability Z greater than 3.5 minus 7 is minus 3.5. Are you with me? So you either use the table or use the calculator and get the answer. Either use the table or use the calculator and tell me the answer. Is it greater than 3.5? Okay. Again. So normal distribution will go for Q, right? PQ. Yeah, how much is the answer? The normal distribution, go with R. R gives you the areas greater than. P gives the areas less than. So with the third one, R minus 3.5, this gives the areas greater than. Okay. So 0.99977 or 0.9998. Okay. So this is the largest probability that you could get for X greater than 3.5. Is this clear? So we'll move to the last part. Find the probability of achieving this value. Okay, so what do you mean by the probability of achieving this value? To achieve this value, what is required? To achieve this value, you need your A to be 7 and you need your B to be 1. Are you with me? A should be 7 and B should be 1 in order to achieve this value. So what's the probability of A being 7? Go to the table. What's the probability of A being 7? 0.15 and the B value probability B is 1 is 0.25. So when you multiply 0.0375. So this is the probability of actually achieving this value. Okay, is this clear? Okay, so this is the end of the June 2020, October 2020 statistics paper.